View or a sneak peek at what's new for steel in Tekla Structures 2021. So let's get straight into it. We have a whole range of new features, functionality and updates for Tekla Structures 2021 that are of great use for existing users of the software or even people that's never looked at the software or used the software before. These range all the way from model productivity and usability, that's how you use the software, the ease of use and how you can learn it, all the way through to drawing production, such as documentation, drawings themselves, CNC production, that kind of thing. Interoperability, how we work alongside other softwares, including our own softwares, and also what's available from our Tekla Structures warehouse, any updates and new features we've got from our warehouse itself. So let's take a step-by-step look at the new updates to the software. And we'll start first of all with the model productivity and usability improvements. So let's start first of all with the instructor side pane. Once activated, this offers instant support on any command, any ribbon command that the user clicks on. So it's great for those that are new to or are learning Tekla, just first starters, but it's also excellent quick reference for experienced users. It's available offline, so you don't have to be connected to the internet to actually use this. And it's available also in 16 languages, which means if once installed, you can quite easily just select the language that you want, and that's the default language in the future. So how does it work? So you can see we've got the commands across the top on the ribbon. If I click, for example, on the column, you can see I've got the tutor activated in the left and the right-hand side. And the command I click on, it will give me a quick visual instruction on how that command works. So what points I need to select to make the, for example, this curved beam, 3 points with a curved beam. Contour plate, selecting the points to define the shape and size of plate that's required. So again, great. If you're new to the software, click on the command. You can see then a quick tutorial in the right-hand pane. If the command's not there as a video, it takes you as well directly into the offline online help. So you can actually get more in-depth help on that particular command. The new part offset feature. This allows faster modification for selected beams, poly beams and contour plates. Quite simply, it's possible to change the offset and rotation of parts with simple keystrokes. This is great for new users, but also experienced users who prefer to use shortcut keys. An example where you'd use these shortcuts would be building a quick engineering model, where you want quick positions, and estimation models, again, where you want quick position of parts. The shortcuts themselves is using the Alt key down, arrow up, down, left and right positions it around its original setting out point. The Alt and space rotates the part through 90 degrees. And we can see how that works. If we click on the part in the Tekla model, using a combination of Alt and space, we can rotate that part around its original setting out point. Using the Alt and arrow keys, we can position it again around its setting out point by moving it around that point. Again, Alt and space. It's not just for I-beams, it can be used on any shape profile. So again, we see a whole range of shapes here. If we select them all, and again use the combination of Alt and space, we are rotating them. And the arrow keys, we're moving those up and down, left and right. Copy and move preview. It's now possible when copying or moving parts in Tekla or assemblies to keep the items shown as solid while they're being positioned. The benefits of that are you can now visually see what and where you are copying and moving to before committing to that change. You get a clear view of the solid position and its location during moving or copying. It works for multi-selection, so selecting multiple parts, selecting assemblies themselves, or even just single parts. In Tekla Structures 2021, it's now possible to keep a visual representation of each part as it's being moved or copied to another location. So I can see here as I copy the angle and the plate, we can see where they're going to be copied from, where they're going to be copied to. It's the same for multi-selection of items, where we can now copy that whole assembly from point to point, and we get a clear indication of where the assembly is being copied from, where it's being copied to. If I now multi-select those, and again select from move from point to point or copy from point to point, I always get a visual representation showing me what's happening before I commit to those changes. Individual items such as these plates can also be visually moved. And that's the same for all objects within Tekla Structures 2021. The contextual toolbar, or the mini toolbar, has been around in Tekla Structures for quite some time now. In Tekla Structures 2021, we now have the ability to create or view drawings for selected parts directly from the contextual toolbar. This gives quick access to drawing production and drawing viewing without having to open the drawing list or to search and find the drawings you're looking for. As we look at a typical project within Tekla, if we select a part or assembly, we launch the contextual toolbar. On the contextual toolbar, you can now see we have the option for opening or creating drawings. In this case, the drawings already exist, so I can quite simply click on the part, click on the contextual toolbar, and open the assembly or workshop drawing directly without need to go into the drawing manager. If I can select then the whole assembly, you can see then we see all the drawings associated with that assembly. I can launch the drawing manager by selecting the full assembly and then saying show drawings for selected objects. This then launches up the drawing manager, the document manager, and actually shows me all the drawings associated with that assembly. If I select this column, we can now see that there are no drawings associated with this column. So I'll now say create the single part drawing directly from the contextual toolbar. And I'll also say create the assembly drawing of that column direct from the contextual toolbar. I can now click on those drawings directly and view them without the need to go into the document manager. Again, let's take a look at the whole assembly. You can see all the assembly parts. Now, going into the document manager, I can still launch that and show all the drawings associated with that particular assembly. And there they all are, without the need for me to find or filter them. The document manager can still be used as before by launching and searching drawings, but the options on the contextual toolbar allow you to quickly view and create drawings without the need to jump in and out of the document manager. Two new setting switches have also been added to Tekla Structures 2021. These allow you to show the hatching for overlapping surfaces. That means if you've copied an object over the top of one another, it's more clearly indicated to show you that there may be a potential problem. But also there's an option to show dashed line for hidden lines. This means if an object is hidden, they can see the hidden lines as clearly shown as dashed hidden lines, not solid lines. This makes it much clearer to visualize and see what's happening behind objects. The benefits are for existing users a clearer view of what you're working with, and new users a much more defined way of understanding how the software works. So you can see here first of all the dashed line for hidden line. The old way of working, you always saw a solid line behind the part when it was shown as transparent. Now you can quite clearly show hidden lines are shown as hidden lines, and that is our recommended setting. New setting switches for duplicates. Hatching of overlapping surfaces. This quite clearly shows if we have identical or duplicate parts over the top of one another. Sometimes this can be intentional or non-intentional, but using this option quite clearly shows that we have parts directly over the top of one another. So two or more parts in exactly the same position. In previous versions, this was shown as a shadowy effect, and we had to rely on clash detection to pick them up. This new way or new selection switch allows you to clearly see those visually on screen and make the decisions on what needs to happen to those. Tekla has developed a special application to test graphic cards in Tekla Structures. This application will test how fast your graphics card is within your computer when it's being used in the Tekla Structures application. It will then report and compare this information against other graphic cards being used by other Tekla Structures users. So this means you can see then very quickly if the graphics card you're currently using is perhaps out of date, high-end or medium, and maybe you can consider upgrading it to get better results. This is great for existing users who perhaps have had hardware for quite a long time, or new users to the software who are needing to check if the hardware they intend to use is really suitable to be used by Tekla Structures. So run the test, get the results, compare and check the speed of your personal graphics card. We also now have a advanced option to show the graphics processing unit on the 3D view itself. So in fact the graphics card usage. It's now possible to show the graphics card being used for Tekla modeling, which is important because sometimes different graphics cards can be assigned for different applications, and just make sure it's correctly configured. It's easy to set up just by setting advanced option, and quickly you can see the results in the bottom left hand corner of the window permanently. So showing the GPU on the 3D view. Again, if we look at a typical Tekla Structures model here, you can see spinning around. We don't know what graphics card we're currently using or it's been assigned to the Tekla application. So if we go to the advanced options, we can turn the show the statistics on, reopen the window, and we can now see in the bottom left hand of the window the graphics card that's assigned to Tekla, in this case the NVIDIA Quadro, and the frames per second being used by the graphics card. So a nice simple visual check that we've assigned and everything's configured correctly. There have been some changes to the way the core of the software handles solids. The solids are now in the local coordinate system with caching of identical solids. This means increased accuracy, less potential for solid failures, especially in thin plate bent parts, faster model opening times, faster, more robust numbering, and please be aware that the diagnose model function will also find any broken solids in the model for you. So here we have a model of bent contour plates within Tekla. I'm now in Tekla Structures 2020. So there we can see an example of a thin plate, contour plates joined together with bends. What I'm going to do now is I'm going to copy up that whole series of plates in the Z direction. And you'll see on this particular model here that we get a few failures, a few solid failures. This is in Tekla Structures 2020. If I now open the same model in Tekla Structures 2021, because of the changes to Tekla, we can now see that all the parts are copied with no solid errors. The opening times and the copying times are also much quicker. Now moving on to batch editing of identical assemblies. This new function has been added to Tekla and it allows users to identify, check and batch edit identical assemblies, such as stairs, handrails, miscellaneous items, particularly pre-engineered metal buildings or modular construction buildings. It allows for quick, accurate copying. It checks the discrepancies between assemblies that should be identical, checks they're all identical for you, and allows for multiple editing of identical assemblies. Here we have a Tekla model with identical assemblies. If I launch the new batch editor command and select those elements, we can then see that those elements are all identical. And we can walk up the list and see the position of every one. If I now change one of those assemblies to be different to the others, so in this case we'll change directions and we'll change the vertical member as well, so it's a different size and a different color. That assembly is now no longer identical to the others. If we run the batch editor again, we can then say, okay, change all the other assemblies to match the edited new assembly. So now you can see that all of the assemblies are identical to the edited assembly. The visualizer. A material editor has now been added to the Tekla visualizer, enabling you to create your own user-defined materials such as transparencies, colors and textures. This allows you to create obviously your own textures, your own custom colors, your own special finishes, and apply those finishes to selected parts or areas in the model, allowing you to overwrite the previous only default rendering options. This is great for new users taking their first step into photorealistic rendering, and experienced users can benefit from this by having access to full photorealistic rendered Tekla models. So let's take a look at this new material editor that's been added to the visualizer. Here we have a Tekla model. If we launch the visualizer, you can see we get the default standards, which is based just on the color you've determined within the model. So while it's photorealistic, they're just standard colors. As you can see here, we're using the slider bar. We can change and create our own custom colors, transparencies and textures. Once we've created that, we can then store that away as our own custom name or our own custom color. So in this case, we'll store that one as green metal. And we'll create another one, which will be red transparency. Once back to the Tekla model, we can then apply those new finishes to certain areas within the Tekla model itself. So generally what we do for grades is you actually apply then the colors, but we can also say then override certain items with these new custom colors and renderings. So there we're going to change that to water. We're going to change these panels to my previously defined red transparent metal. And we're going to set all this part of the area here as my stored green metal finish. If we now start the visualizer again, you can see that the items have been changed to the custom renderings. So animated water, red transparent panels, and metallic green finishes. Excellent for creating superb, impressive 3D photorealistic rendering and animations. The latest version of Tekla now fully supports the creation of blind and partial holes. Blind holes are holes that only go certain depth into the material. Partial holes are just partially drilled on the edge of the material itself. You can also have partial blind holes, which are on the edge and only partially drilled some of the way down the material. We fully support all the manufacturing data from this, including DSTV exports, STEP and IFC. These are particularly beneficial for detail and fabrication of curtain walling, light metal frame, architectural and miscellaneous items, special steel needs, concrete anchors and milling operations. It's been a long request from our users for a support for blind and partial holes. Here you can see examples of some curtain walling where the holes are just drilling through one side of the material, or milling operations just partially down the edge, but also blind into the material. Again, some of the examples of this showing the operations within Tekla and the actual material that's created. So here we have a Tekla model, just two simple plates with bolts going all the way through. You now have the option to set those holes to be blind, which makes those partial depth. You can type in the depth of the hole itself or make it again all the way through. The direction of the bolt changes whether the blind hole comes from the bottom of the plate or the top. Also, you can see there we have the partial bolt or hole, which is on the edge of the material. Again, we can have blind partial holes, so a combination of the two, where you can easily change the depth of these bolts and the position of them, of the holes. Again, make that through. The hole now goes all the way through the material. Also, the bolt functionality has been improved so that bolts passing through multiple layers in bent plates and poly beams now unfold correctly in drawings and CNC production. So an example here would be this glue lamp connector, where we've got bolts going through one side of the plate, through the timber element, and through to the other side. So you can see there, that's the kind of situation that we're looking at. In Tekla Structures and earlier versions, the bolts going through to the other side of the plate would not unfold correctly. Now these are fully unfolded correctly in drawings and CNC production. So you can see, for example, the original drawings in version 2020 and earlier. Now in version 2021, the relevant data is created correctly, making this functionality much more usable. Now moving on to the improvements to the drawings, we have new associativity rules. This allows you to clearly see what object the dimensions are being dimensioned and associated with. You can quite simply turn this on by going to the settings and turning on the dimension creation associativity. This allows you, when you're adding dimensions or even looking at dimensions that are being created automatically, to check exactly which model object the dimension has been attached to or anchored to. This means then if you clone the drawing in the future, you can ensure it's been cloned or edited to the exact dimension it was originally associated with. So in this case here, make sure this dimension always follows the bolt. Make sure this dimension always follows the top of the plate, and so forth. It also comes into use when using tagging. So if you're adding a dimension line and you want to add content tagging, we can then see as we move along and add the dimensions, we can make sure that the object that we are associating the dimension with is shown quite clearly, and we can make sure the tagging reflects the object it's being tagged to. So here we have a drawing, a simple truss drawing, and I'm going to manually add some dimensions to this drawing. You can see as I walk through and add the dimensions, it's asking me which element do I want that dimension associated with. Now I can go back and click on the dimensions and show those and say actually I want that dimension always associated with the vertical. So if I clone that drawing, it will always associate it with the vertical and move it accordingly. If I now add content tags to that dimension, it will reflect as well the objects I associated the dimension with. So in this case, 2 end plates, 5 verticals. If I add another dimension now, this time going to the sloping elements, again add those dimensions along the part and to the end plate, you can see there we have the dimension and tagging, 2 end plates, 4 sloping. And you see quite clearly then those dimensions are associated with those particular parts in the drawing itself. Working alongside the new associativity rules, we now also have improvements to the cloning functionality. This allows you to produce better quality drawings, create the drawings faster, benefit from better robust behavior, and reduce the number of errors when creating drawings using cloning. So let's take a look at improvements to the cloning functionality. Here we have a model with 5 similar but not identical assemblies. First of all, let's open up the drawing which I edited earlier. This has been created using the associativity rules and the tagging content. If I now create these 4 remaining assemblies and use the drawing I created earlier as the basis, or clone from that particular drawing, and we open up the first of those cloned 4 drawings, you can see that the rules and tagging content has followed what I determined on the original drawing. So the content of the tag has changed to suit the new assembly, but still based on the rules I set on the original. And that's the same for all of these remaining cloned drawings. Drawing-specific table positioning. This new functionality allows you to move any drawing template, such as a list or a call-out, to any other location on the drawing. Quite simply, select on the template you'd like to move, right-click on it, select the option Exclude Template from Layout, and move it to another location. This is great for expert users who want to simply rearrange a drawing quickly, or for new users who want to create a drawing of a particular style. It's considered when arranging drawing views, and it's also considered when cloning drawings. However, it's specific to that particular drawing that you have edited. So you can see here, click on the template to move, exclude from layout, and move it to any location on the drawing that you require. Here again, we've got a truss drawing. We're going to click on a template and say exclude that template from the drawing. That means I can move that individually to another position. Again here, exclude that template from the drawing, move it to another location. So let's say I'm making more room for that truss to fit in the more upper corner of the drawing. So again, I'm going to move that across, move it down into position. And I'm going to select the final template, right click on there, exclude from the drawing, move it along, reposition it down, and it's in its new location. If I now arrange those drawing views, it takes those into consideration and arranges the drawing into the position and format that I'm more happier with. Cloning of a drawing edited with drawing specific table positioning. So here we have the original drawing. I've just moved the templates around in the drawing, and I'm now going to clone these remaining assemblies based on the original drawing in which I've moved around the templates. The clone drawing will also now inherit that template location. So if we open up the first of those drawings, we can then see that the table positions are exactly cloned from the original. Trimble Connect, overlay model versions and change detection. This new functionality allows you to detect model revisions and keeps a full history of all the uploads and changes using Trimble Connect overlay models. This means two versions of overlay models can be set visible at the same time to be compared on top of the Tekla model. The comparison between the models will then show the differences visually and be color coded. This is great for people working on projects where they can quickly identify physical changes that have been made to the model and uploaded to Trimble Connect. This helps in detecting reference model upload revisions and keeps a history of all the uploads so that you can look at the changes between the first upload and the final upload, or the first and second upload, etc. To use these new functionalities, you need to have the model attached to a Trimble Connect project. Here we have a Tekla model that's already been attached to a Trimble Connect project. It's been uploaded several times in the past, but in this case we're going to make some simple changes and re-upload the model one more time. Once the model has been uploaded to Trimble Connect, we can then compare the versions of the models in Trimble Connect on top of the Tekla model. So here we can see the final version of the model compared against the last update. Or we can compare the first version of the model to the second version of the model, or the first version of the model to the final version of the model. We can then use the interface as well to zoom in on parts that are physically changed. By clicking on the interface, clicking on the part, it will zoom in automatically on the part that has been modified, added or deleted. We can choose to show only new items, deleted items, or revised modified items. So moving on to our next part, what's new for Steel 2021 with regards to extensions from the warehouse. Again, a whole new range of extensions or updates to extensions, all the way from installing and uninstalling applications to new applications such as the new light metal frame tools and the crane tools. Great, again, if you're an experienced user, some great applications here. Or if you're new to the software, some lovely applications to make using the system more simpler and more relevant to the work that you do. So first, let's take a look at the TSET Manager. The TSET Manager is a simple way for you to manage your already installed extensions. You can search the extensions by name, the Tekla version, or even the type of extension. It allows you to, most importantly, allows you to install several extensions at the same time. So this is great if you're wanting to tidy up. If you've been using extensions, some you're not using anymore, you can delete all those in one go. It's great for new users, allows you to put extensions in and manage them quite simply. So let's take a look at how that looks. So here you can see, here's the TSET Manager being run. We can search by version number, so let's say Tekla Structures 2020, and we can find everything under that name. Or we can search by an extension type, so in this case the issue tool, and we can say I want to remove all the issue tool installations. So cleaning up my Tekla system very easily. So the TSET Manager, a particular favourite of mine. Linking documents to Trimble Connect. This tool's existed for a while, but now it's been updated to be more user-friendly and much more functional. So this tool automatically links drawings from your Tekla model directly to the Trimble Connect model. So you can click on a part in Trimble Connect and view the drawing quite easily and simply. when you upload the drawings, they're automatically converted to either PDF or DXF format while they're being uploaded. So it's a nice, simple and easy way to use this. So again, here we have a Tekla model. We can see all the drawings have already been created. I've done my editing what I need to. I've also got all the NC files created for the model. I'll now run the extension, linking documents to Trimble Connect. I'll select the IFC file I want to link the drawings to. So this has already been uploaded to Trimble Connect. Then I'll select the drawings and we'll upload and save and link the drawings automatically. Once that's finished, if I then go into Trimble Connect and view the model, click on a part, click on the drawing, we can simply view the drawing directly from the Trimble Connect model. A nice simple way for me to attach my drawings to the Trimble Connect model easily and simply, and share that model with anyone around the world. The Excel to Drawing extension. This allows you to import an Excel spreadsheet directly into a Tekla Structures drawing. It can be positioned at any location and it works for all types of Tekla drawings, such as single parts, assemblies or GA drawings. Once the Excel sheet has been imported, if the original Excel update gets updated, it automatically updates itself in the Tekla Structures model. Here we have a typical Tekla Structures model with a GA drawing already created. I'm going to run the Excel to Drawing extension, point to the Excel sheet, and it's imported directly into the Tekla model. I can click on that sheet and move it to any position, but I can also change the color and style of the cells as appropriate to what I'm looking for. The spiral stair tool has been with us for quite some time now. It allows you to easily model spiral staircases of all different types and styles. Very well utilized tool, and it's the first one that uses a dynamic interface where you can actually drag. You've got toolbars where you can drag them to create the shape of the staircase you're looking for. It's been updated for 2021 to include now the option to unfold parts by a specific length, so you can define stringers so they can be unfolded, let's say by 2 meter length, by 3 meter length, and it's been a long-standing request from our users. So again, I'm running the tool here, as you can see, selected from the extensions, into position, define it as 2 meters high, and you can see quite easily I can click on the interface and change the type and style of staircase to the style that I'm looking for. Again, a great tool for new users that are detailing spiral staircases, simply filling in the dialog box to get the type of staircase that you're looking for. Again, you can see I've defined the stringer length as 1 meter. I'll now change that to 1200. That means when those parts are now unfolded, they're at the correct length. So you can see now the unfolded part for that stringer is 1200 as defined in the interface. The straight staircase extension. This new straight staircase tool offers a faster and more flexible modeling experience for standard straight staircases. This new tool uses a combination of direct modification and a property pane to input the parameters, so you can manage your stairs in a what you see is what you get modeling environment. Select the tool from the toolbar and place directly in the model. All parameters can be changed by simply selecting them from the input box in the right-hand window in the property pane. By clicking on the staircase direct, we can use direct modification to change all parameters such as height, width, and so forth. For changes particular areas like the landing, we can click directly on the landing elements and change those directly by typing in the parameters using direct modification. We can also change the type of connection that we're using by simply clicking on the connection tab and choosing the tab from the regular component toolbox. The issue tool is a more classic issue to production, revision and change log system. You can easily find out what's changed in the model and in the drawings between issues. You can export the results to Excel or CSV for your records. And the new version of this issue tool brings substantial improvements in the terms of workflow. Again, here we have a complete model ready for sending to production. So we have all the drawings complete, At this stage then we can make an issue or take a snapshot of the model using the issue tool. This then will keep a history of the issue at this stage. So let's say in the future I make some changes, such as we've been requested to move some holes, change some welds, add additional beams. We can then make the changes to the model. Once we've made the changes, we can then update the drawings and take another snapshot of the model. We can then compare the two snapshots and it will give me a full history to show what's changed between both revisions. So we can see here, these parts, the quantity has been decreased. These parts have been changed. So their quantity has been increased by 8 because we've included all those stiffeners. We can add a revision automatically to the drawings using the issue tool. And if I now open up the change drawings, you'll see they're clearly marked on the drawing automatically with the revision between each issue and showing the change what occurred for that particular part. In this case, the status has been changed. Again, anytime you can export that to CSV or Excel format for your records. Working with built-up sections or plated sections. So these are beams that are made, for example, with 3 plates, or C sections that are made from 3 plates. So web and flange plates welded together. The Convert Built-Up to Plates extension contains 2 tools which will help you in the detailing of these kind of elements. It's useful in many industries where plated elements are used, such as offshore and pre-engineered structures. The first tool is Plates from Built-Up Section, which converts a selected beam from the assembly and creates a copy of that, but as a built-up section. So the original UB remains there, but you've got a copy of that as a plated section built from 3 plates. The second tool, the Plate Beam Converter, converts the assembly fully into a built-up section. It welds those plates together and it keeps all the original editing that you've done on the original beam. So any plates, any welds, any fittings, it just completely converts it into a built-up beam seamlessly. So let's say, for example, you could detail a beam using a UB section. You could do all the cuts, all the welds, put all the fittings. Then using this tool, you can click on that and convert it into a built-up beam. It works with tapered sections. It works for I sections, beam sections, L sections, angles, C sections. In fact, any structural section this tool will work with. So let's take a look at these new tools. Plates from Built-Up Section contains 2 tools. So we'll look at both of those tools independently. Here you can see we have an assembly. It's built from just regular I sections, so profiles directly from the catalogue. So there we've got beams, we've got stubs, we've got plates. I'll now use the Plate from Built-Up Section extension. This is the first tool. The options I get really are just the naming of the sections when they're being converted. I click on the assembly, click in space, and it creates me a duplicate of that assembly, but as a built-up beam, or the main part of the assembly, or the selected part of the built-up beam. So if I now select the channel, you can see there I've got the channel as a built-up channel, but the original channel still remains. So again, the stub, there now that's done as a built-up stub. The second tool, the Plate Beam Converter, same thing, I've got the choice of naming, and then if we run this, we can quite simply click on the main part of the assembly, click on the middle button, and it will convert the main part into a built-up beam, but all the editing that I've done, all the macros, all the components will remain there, and I get now a built-up beam from the original assembly. So again, if you zoom into there, you can see now I've converted that into a built-up beam, and it's all welded together. Again, I can do it with the channels at the bottom, so I'll do those individually. So we'll click on these 2 channels, middle mouse button, and it'll convert those into built-up beams, or in this case, built-up channels. Again, the stub, click on there, run the converter, and it converts that into a built-up section. Again, with all the editing and welds as it was previously. I can actually put a window around the whole assembly and do that in one go as well, if I want to convert everything. So there, click on the whole thing, middle mouse button, and it converts the whole assembly into built-up parts. Super effective and productive tools. Great if you're new to the system and you're not clear on how to work with built-up beams. This is a really nice, simple way of working with built-up beams, and it's great for expert users as well. Tools for light metal framing. the framing tool extensions. These new extensions contain general framing tools for creating modular, cold rolled steel panels, walls, roofs, trusses, floors and openings. You can model multiple panels along the whole floor perimeter in one go, so simply go all the way around the floor and it breaks the panels into the designated length. Direct modification allows modeling of roofs and trusses in any direction. Panel opening allows you to create spaces for doors and windows easily, and the panel ensures that everything fits together correctly. I'm just actually going to give you a flavour of how this system works, but you can watch a real live demonstration from the link shown below. Here we have a reference object I've placed, which is going to be my basic layout. I'm going to run the framing panel application and then just simply select from point to point. I've already designated that the length of these panels should be 3 meters. This application will break them down into 3-meter panels. And you'll see those are now created. All the options for the profile sizes, bracings are all within the framing panel macro. I can then simply add openings by choosing from the toolbar and selecting from point to point. Larger openings are easy to find as well, spanning along multiple panels. These new tools make life much easier, especially if you're new user to the software. And again, I'd advise you to take a look at the video in the earlier slide to take a full overview of these new light metal frame tools. And finally, we come to the crane planning, the new crane extension, the crane tool extension. This allows you to plan tower, crawl and mobile crane positioning and load implications. Lift checking for capacity, range, height, and lifting, of course, from the supply point where the material is stored. We can do lift simulation to show you how parts will lift and if the parts that become red are actually out of capacity. And then you can also do an erection time calculation using the software. Fantastic new software, very easy, very simple to use and runs within the Tekla application. I'm just going to quickly give you a flavour of this. We do have a full video of the crane tool in depth, and again it's something I advise you to take a look at. So looking at the crane tool, just briefly going into it, you can see we have the crane tool running within the Tekla model. You can see we can reposition where the cranes are, where the lifting points are, what the capacities of members, what weights, when the span. We can then see that the position of the crane defines whether the parts are erectable or non-erectable. And we get a capacity check that those parts are all feasible to be lifted with the crane position where it is. Again, there's a full video explaining how the crane tool works. I would advise you to take a look at that in depth if this is of interest, which I'm sure it is for steelwork erectors. A brilliant addition to the Tekla software.